This chart compares Earth's temperature history with its sea level history for a period of time from the present on the right all the way back to 550 million years on the left. The temperature history is depicted in the lower chart, the sea level history in the upper chart. This composite chart consists of 5 discrete sections or 5 discrete panels. The first panel covers a period of time from the present on the far right to 20,000 years ago on the left side of the panel. The second panel covers a period of time from 20,000 years ago on the right to 1 million years ago on the left. The third panel covers a period of time from 1 million years ago on the right to 5.5 million years ago on the left. The fourth panel covers a period of time from 5.5 million years ago on the right to 66 million years ago on the left. And the fifth panel covers a period of time from 66 million years ago on the right to 500 million years ago on the left. The temperature chart shows deviation in Earth's temperature based upon the average of our present temperature. The temperature gauge is shown here ranging from plus 25 degrees Fahrenheit warmer than today's temperature to minus 10 degrees colder than today's. Today's average is depicted in this black line you see here, and the period of time used to create the average is a period of time between 1960 and 1990. The sea level chart depicts the sea level based upon values above and below today's value. Today's value is considered the zero value as depicted by this blue line you see going across here. The scale for sea level values are defined here in meters. The sea level values will go down from 0 at present to about 140 meters below present value, and as things changed and the sea level got higher, those values will go up from 0 to approximately 400 meters higher than today's value. For most of the past 5.5 million years, sea level has fluctuated generally in sync with the Earth's temperature. This has much to do with the melting and advancement of glaciers, primarily in the northern hemisphere. I'll point out that this period of time, the last 10,000 years, is considered an interglacial. That's where glaciers have retreated and the Earth is in a warm period. In the previous 4 interglacials, and these are running about 100,000 years apart, are due to Milankovic cycles. The temperature at those interglacials was actually higher than it is today by about 5 degrees Fahrenheit, as you can see here. Additionally, sea level actually was higher than today's value for several of the preceding 100,000-year cycles. Specifically at the last interglacial, which happened about 125,000 years ago, the sea level peak actually at about 8 meters higher than today's value. Now 8 meters is 26 feet. For periods of time further back than 5.5 million years, there is some general correlation between temperature and sea level, but it's not the same. The general trend of sea level was often affected by things such as the position of the continents, which were changed by plate tectonics. And also, even though there were a few ice ages during the last panel's period here, that didn't necessarily represent low or high sea levels, because the arrangement of the continents on the Earth greatly affected where sea levels ended up. Now, with respect to temperatures, I've already mentioned the temperatures during the most recent previous interglacial were higher than today, but as we get back in time past about 3.5 million years ago, Earth's temperature was above and stayed above for the most part the present value. In fact, back here at around 5 million years ago, it was running almost 25 degrees higher than today. The same thing happened back at about 500 million years ago. It really spiked, and that was about 27 degrees above today's value. Also, with respect to sea level, although sea level generally stayed below today's value for the most part until about 3 million years ago, after that time it slowly increased. And then beginning about 66 million years ago, it took some giant spikes. Here at 66 million years ago, you can see it's almost 250 meters higher than today. And if we go back to about 475 million years ago, you can see the sea level is running more than 400 meters higher than today.